In this video, we are going to learn how to find missing side lengths and missing areas with two similar figures. The relationship between a side length ratio and an area ratio is that the side length ratio, be it A over B, the area ratio will be A squared over B squared. This happens when you, for example, take a square that is let's call it side length A and side length A. If I were to double both side lengths, 2A, 2A, let's say I find the area of these. The first one's going to be A squared, A times A for a rectangle. The second area is going to be 2A times 2A, which I'm going to rewrite as 2 squared A squared. So the A squared term, factor here, look at the coefficient of the larger area. It's 2 squared. Now we doubled the side lengths or multiplied them by 2. That's what these 2's are for. But the area did increase by a factor of 2. It actually increased by a factor of 4, which is 2 squared. Which makes sense because you have two 2's multiplying together in the area formula. If I were to triple the side lengths, this would be a 3 and this would be a 3, and you have 3 squared. So the areas change in a squaring ratio rather than an actual A to B ratio, which is why this exists. So if side lengths are an A to B, that means the area ratios are an A squared to B squared. Now to convert back and forth between these, if I'm going from side length A over B to area ratio, side length ratio here, you're going to square the side length ratio to go from side length to area. If you're going backwards from area to side length, you're going to square root, the inverse of squaring something. You got to keep this in mind when you go back and forth, because if you square an area ratio, you're not going to get the side length ratio and vice versa. So, looking at this example here, they tell you that the two triangles are similar. They tell you the area of triangle ABC is 108 square feet. Find the area of triangle HGF. Start with the question. What are they asking us to find? They're asking us to find an area. In order to find an area, I need to find the area ratio. So the first question is, what is the area ratio? Since I only have one area, I can't make an area ratio. But the next question I can ask is, if I had the side length ratio, I could square it to find the area ratio. So the next question is, what is the side length ratio? Do I have side lengths in this picture? I do. 48 and 8, for example. 48 over 8 is 6 to 1. That is your side length ratio. And I simplified it 6 over 1, side length ratio. I need to find my area ratio. So I'm going to square it to find the area ratio. So the area ratio is going to be 6 squared over 1 squared, which is equal to 36 over 1. Now I have my area ratio. Now that I have my area ratio, I can find an area that's missing within an area proportion. So put this 36 over 1 into your proportion, and on the other side you have two factors. You got 108 and you have the missing area, which we're going to call x. 108 is triangle ABC. It's very important you put this in the correct spot. ABC is the larger triangle. Therefore, it is the larger area. Therefore, it goes with the larger number 36. HGF is the smaller triangle. Therefore, it goes with the smaller number because it is the smaller area. So if you do this correctly, you should expect to get an area less than 108 square feet. Cross multiply, 36 times x is 36x. 108 times 1 is 108. Divide both sides by 36, and you should get x equals 3. That's 3 square feet for the area. So to recap, they asked you to find an area. In order to find an area, you need an area ratio. We don't have one of those. So we use the side length ratio that we know. We squared it to get 36 over 1. Then we use that area ratio to find a missing area with an area proportion. Just cross multiply and solve here, and you get 3 square feet. Now let's say they don't give us a side length ratio, but rather they give us an area ratio. So this example here, they tell you ONM triangle is similar to QRP triangle. And the area of OMN is 9, and the area of QRP is 49. So they give you an area ratio. They want you to find ON. ON is here. Okay. So you may be asking yourself, well, what corresponds to ON? Well, it's clearly QR. But I don't have a side length ratio. So the question is, what is the side length ratio, or the side ratio? We don't know it. But in order to find a side length ratio, you could use an area ratio. So what is the area ratio, you ask? Do we have one of those? In fact, we do. It's right here, 9 over 49. So if I'm taking my area ratio and I want to go back to a side length ratio, I'm going to square root it. So a side length ratio is going to be the square root of 9 over the square root of 49, which is 3 over 7. That is your side length ratio. Now that you have a side length ratio, you can find a missing side length. So use that 3 over 7, put it into your proportion. And again, the order in which you write the second ratio matters very, very much. We're going to call this x. Now 36 is in the larger triangle. 7 is the larger number in this fraction here. So 36 is going to go with the larger number 7. X is in the smaller triangle. Therefore, it goes with the smaller number 3. I'll draw little arrows there to remind yourself you can. But that second order matters very, very much. If you have that out of order, you're not going to get the correct side length. Cross multiply, 7 times x is 7x. 3 times 36 is going to be 90 plus 18, so 108. Divide both sides by 7. X is going to be equal to approximately 15.43, and the units are inches. That's a length, not an area, so it's not square inches. So remember that it is a side length. You're not going to use the square inches. You're going to use just inches. So to recap, if you're looking for an area, you need an area ratio. If you don't have one of those, you need to find one using the side length ratio and squaring it. If you are looking for a side length, you need a side length ratio. If you don't have one of those, you need to take your area ratio and square root it. You definitely need to know how to go from a square or a side length ratio to an area ratio and back. The order in which you, or the direction in which you go between them, determines whether or not you square the ratio or whether you square root the ratio.